Hi children, welcome to exercise 5.3, question number 1. List the outcomes you can see in these experiments. A. Spinning a wheel. B. Tossing two coins together. First, what is meant by outcome? An outcome is a result in an experiment. So if you do an experiment, there may be so many results. Each result is called one outcome. Suppose if you toss a coin, you may get head or you may get tail. So head is one outcome and tail is one outcome. Here we have spinning a wheel. So spinning a wheel means here we have A, B, C, D, again A, 5 portions on a spinning wheel. Now if you spin this wheel, this pointer will stop at on any portion. So maybe on A like this, maybe on B, or maybe on C, or maybe on D, maybe on A again. But it will stop only on one portion. When the pointer is stopped on A, then that is called one outcome. When the pointer is stopped on B, then that is also called an outcome. So in the same way here, we have what are the outcomes? Outcomes means on what portions can this pointer be stopped? On A, on B, on C, on D, or on again A. So the outcomes are A, B, C, D, and again A. We already wrote A, so need not to write again. So A, B, C, D. These are the outcomes. Outcomes means nothing but results occurred in an experiment. Now let us come to tossing two coins. Whenever you have two coins and two coins are tossed, what are the results can occur? Let us see all the possibilities. These are the 4 possibilities when we toss two coins. This is called tail and this is called head. So what are the possibilities? Both may be heads. In this case, head, head. First head, then tail. So head and then tail. First tail, then head. So tail, head. Then both are tails. So these are the 4 possibilities we have. So the answer is head, 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 tail, head, or tail, tail. Exercise 5.3, second problem. When a die is thrown, list the outcomes of an event of getting a prime number, not a prime number, a number greater than 5, a number not greater than 5. Before going to answer these questions, when a die is thrown, what is a die? List the outcomes means what are the total outcomes. Let us see. First of all, what is a die? A die is a 6-faced cube. 6-faced cube. So we have 6 faces. On each face, one number will be printed. 1, 2, 3, 4, 5, 6 like that. On one face, there will be 1. On another face, 2. On another face, there will be 3 like that on 6 faces. In each face, there will be one number printed. So let me show you. Now you can see here, we have 2 kinds of dice. In the first diagram, you can see a red colored die. In this die, just dots are there. You see here, there is 1 dot here. Here we have 4 dots. Here 2. And here 3. Here 5. Here 6. Or in the bottom diagram also we have 1, 2, 3, 4, 5, 6 like that. Numbers are printed on that one. So there may be dots or there may be numbers printed on each face. By observing this, what are the total outcomes? So total outcomes means if you throw a die, then you may get one of these 6. That means maybe 1, maybe 2, maybe 3, maybe 4, maybe 5, maybe 6. So total outcomes are 1, 2, 3, 4, 5, 6. These are the total possible outcomes actually. Now let us take first problem. In that A, list the outcomes of an event of getting prime number. What is an event? Event means nothing but collection of outcomes. collection of outcomes is called an event. A prime number. Out of these outcomes, what are the prime numbers? You see 2, 3 and 5. These are the prime numbers. So an event of getting a prime number has the outcomes 2, 3 and 5. Next, let us see B. Not a prime number. Out of these numbers from 1 to 6, what are the numbers which are not prime? So prime numbers we already wrote. Write the remaining numbers. Remaining numbers are not prime numbers. 1, 4, 6. These are the numbers which are not prime. Now let us go to the second one. A. Number greater than 5. Number greater than 5. What is the number we have greater than 5? Just only 6 we have. So 6 is the answer for this one. Next, B. A number not greater than 5. Not greater than 5 means maybe less than or equal to also. Not greater than 5. So 1, 2, 3, 4, 5. Not greater than means it doesn't means less than 5. Not greater than 5 doesn't mean less than 5. Not greater than maybe equal to also. So we need to write 5 also here in this case. Exercise 5.3, third problem. Find the probability of the pointer stopping on D in question number 1A. Here is the spinning wheel. Now what is meant by probability? Probability is probability equal to number of favorable outcomes by total number of outcomes. Total number of possible outcomes. This is what is meant by probability. So first let us see the first question. A. Probability of pointer stopping on D. So here we have a spinning wheel. How many portions are there? 1, 2, 3, 4, 5. So there are 5 portions. A. So probability equal to probability of getting D or stopping at D equal to number of favorable outcomes divided by total number of outcomes. Total number of outcomes, how many we have? 5 actually. Why? Because there are 5 portions. Now D has how many portions? Just 1 portion. So 1. So 1 by 5. This is the probability in question number A. Let us go to B. Probability of getting an ace from a well shuffled deck of 52 playing cards. First let us see what are the playing cards. You can see on the screen we have all 52 playing cards. Here in the first one we called A. This is A. You see, in all these 4 we have A. This is called ace. Then we have 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we have J, that is called jock. Then we have Q, that is called queen. Then we have K, that is called king. In each of the set we have how many cards? 13 cards we can see. Here 13, here 13, here 13 and here also 13. So in total we have how many? 52 cards. So in a deck of cards we will be having 52 cards. Now out of these 52 cards, pick up one card randomly. How many total possible outcomes will be there? You can get any one of these 52. So total number of outcomes will be how many? 52. Now we need to get ace, an ace. How many aces are there? 1, 2, 3, 4. Here 4 aces are there. So you may get any one of these 4. So total possible outcomes is 52. The favorable outcomes to get an ace equal to how many? We have 4. Probability P equal to number of favorable outcomes divided by total number of outcomes. Total number of outcomes. So number of favorable outcomes, that is equal to 4 divided by total number of outcomes, that is 52. So we can cross out. So we will get 1 by 13. So the answer is 1 by 13. Let us go to question number 3. Probability of getting a red apple. See the figure. Here, how many apples are there in total? 1, 2, 3, 4, 5, 6, 7 apples there. So number of, this is for question number 3 or C. Number of apples equal to how many? 7. Whether it is green apple or red apple, doesn't matter. How many apples are there? 7 apples. If you randomly pick up one apple, it may be red or it may be green also. Now we need to get red apples. How many red apples are there? Let us see. Number of red apples. Number of red apples. 1, 2, 3, 4. So that is equal to 4. So therefore probability of getting a red apple is equal to number of favorable outcomes. Here means number of red apples. So number of red apples divided by total number of outcomes means here total number of apples. Total number of apples. So that is equal to number of red apples. How many we have? 4. So divided by number of total number of apples equal to 7. So 4 by 7 is the probability in question number C.